So now we want to take a look at some exercises using our properties to write in a logarithmic expression in expanded form. So we want to express as a sum or difference of logarithms and simplify. Keep in mind that if I come across something like log base b of b to the r, that's going to be equal to r. I'll be able to simplify that. So if I take a look at this first one, I have a 5 and a z in the numerator. Those are my factors in the numerator. Those logs are going to be positive. I have a w in the denominator. I'm going to have a minus sign in front of that log. So we're going to rewrite this as log of 5 minus log of z, plus log of z minus log of w. And my base here is 3. I need to make sure I write those in. And so that would be our answer in expanded form. For number 11, we've got log base 7. I have an a and a c in the numerator, so it's going to be log base 7 of a plus log base 7 of c. And then the denominator, I've got this 49 and d, so it'd be minus log base 7 of 49 minus log base 7 of d. Now this one I need to be careful of because this is the same thing as log base 7 of 7 squared. On composing a function with its inverse, that's going to simplify to 2. So I'm going to end up with log base 7 of a plus log base 7 of c minus 2 minus log base 7 of d. Let's try number 12. They're both in the numerator. There is no denominator, so this is natural log of x squared minus natural log of y cubed. But now I can bring these powers out in front. So let's go ahead and do that. So this would be 2 natural log of x minus 3 natural log of y. Let's take a look at number 13. So I have an a to the 5th in the numerator, so that's natural log of a to the 5th. And then I have these factors of w in the denominator, so it'd be minus natural log of w minus natural log of z. We go ahead and bring the 5 out in front, so it'd be 5 natural log of a minus natural log of w minus natural log of z. And here I wrote it without the parentheses because that's usually how they write it in ALEKS and also in the textbook. Alright, let's take a look at number 14. So we have a 16, a to the 4th, and b to the 7th in the numerator. So that'd be log base 2 of 16 plus log base 2 of a to the 4th plus log base 2 of b to the 7th. In the denominator, I have a c squared and d to the 9th, so that'd be minus log base 2 of c squared minus log base 2 of d to the 9th. Now if I take a look at this log base 2 of 16, 16 is a power of 2, it's 2 to the 4th. So composing a function with its inverse, we're just going to get a 4 for an answer. So that first part's going to be 4. I'm going to go ahead and bring this 4 down. So that'd be plus 4 log base 2 of a. Bring the 7 down, plus 7 log base 2 of b. Bring down the 2, minus 2 log base 2 of c. And bring down the 9, minus 9 log base 2 of d. Ooh, that was kind of a long one. Let's try this next one. So I have a factor of 64, a factor of x squared, and a factor of y. In the denominator, a factor of 3, a factor of z, and a factor of w cubed. If I look at this one, that's log base 8 of 8 squared. That's going to yield me 2. So that's going to simplify to 2. On the other ones, I'm going to bring the exponents out in front. So I'm going to put that 2 in front. Log base 8 of x. And I'll write it without the parentheses, because that's how they write in ALEKS in the textbook. Plus log base 8 of y. Minus log base 8 of 3. Minus log base 8 of z. And then bring the 3 out in front. Minus 3 log base 8 of w. Now, one thing you'll notice in mathematics, anytime we develop a technique or a tool, we then use that tool backwards. And so the next set of problems, that's what we're going to do. We're going to start with something like this and rewrite it as a single logarithm. So here we're going backwards. It's like running our movie backwards. So any number that I have in front of the logs, I'm going to need to bring up as powers. So like I would first write this as log of 4 minus log of x squared. Or like over here, I'd write this as log base 2 of z to the third plus log base 2 of y squared. Kind of run the move about, bring those back up as powers. Here I've got subtraction, so I'm going to rewrite that as the log of the numerator over denominator. Here I have addition, so I'm going to rewrite that as a product. So it'd be log base 2 of z cubed times y squared. So that would be our answer. All right, let's try this next one. So again, I'm going to start with the numbers in front of the logs, bring them up as powers. So this would be natural log of z cubed minus natural log of 5 plus natural log of y to the 7th minus natural log of p squared. Notice I don't bring up the sign, I just bring up the number. because the sign is going to tell me where if it goes in the numerator or denominator. So looking at this, the z cubed and y to the 7th, both those logs are positive, so those factors are going to go in the numerator. We have the 5 and p squared. There's minus in front of those logs, so those have to go in the denominator. Let's take a look at this next one. So again, I'm going to bring up the 2, the 4, and the 3. Now, I have more than one term, so I'm going to be a little careful how I write this. So I'm going to write this as log base 3. I'm going to use some square brackets. 3x minus 1 squared, square brackets, just to make it clear that I'm squaring the 3x minus 1. And I'm going to do the same thing here. Log base 3 of 2x plus 5 to the 4th power. And then the last one would be plus log base 3 of x cubed. Now this one's a positive log and that's a positive log, so those factors are going to go in the numerator. And I'll tell you what, I'm going to go ahead and put that x cubed, just to make it a little easier to read. I'm going to put the x cubed in front, then the 3x minus 1 squared. Just makes it a little bit easier to read. And then the 2x plus 5 to the 4th power has to go down at the bottom, because there's a subtraction in front of that log. So that big old mess will be your answer. All right, let's try this one. So again, bring up the powers. So this is log of x to the 5th minus log of y to the 8th minus log, again, I'm going to be careful here because I got more than one term, y minus 8 to the 3rd plus log, and again, I want to be careful here, x plus 3 to the 6th. And let's see, this and this are positive logs, so those factors are going to go in the numerator. So I'm going to have x to the 5th times x plus 3 to the 6th. And then these folks have negatives in front, so those factors are going to go on the bottom. And so we'll write that as y to the 8th minus y minus 8 to the 3rd down that denominator.